2010B, question 12. Anne and Bob live in an area infested by mosquitoes, but it is possible to control the problem by spraying an insecticide. Okay? This is just a descriptive sentence. But anyway, what we see here is this. There are two individuals, right? There are two individuals. So whenever you see two individuals, there's a chance that it could be an externality or probably good question, or an H-Wolf box question. Okay. Any spray that is used affect both residents equally. Okay, the impact, as long as you use a spray, it affects both residents equally. The spray is available in standard size cans, and the market for spray is competitive. Okay, what do you mean by market for spray is competitive? Whenever you see this thing, this market is competitive, they just try to tell you that the price is given. Price P for that means the price of spray is given. That's all. That's what when they bring in the word competitive, a lot of time in the context. So that means you take the price as given. That means how much cans you buy will not affect the price of cans. Understand? Let XA and XB denote the number of cans sprayed by Anna and Bob respectively, and let X equals to XA plus XB. Okay? So you know XA and XB is the number of spray they use, and total X equals to XA plus XB. Okay. Now, Anna utility function is given by UA, blah, 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 and Bob utility function is given by UB, blah, 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 blah. They give you what? Two utility functions. Okay? How much Anna choose her variable? That means the choice variable. How much can Anna decide? Will it affect Bob? Yes. How much spray Bob choose to buy? Will it affect Anna? Yes. Right? Because the more spray I buy, I will affect the other party positively. From all this context, you know it would be an externality or probably good question. Okay? Okay, set up the stage one by one. Two utility function, individual A, individual 1 and individual 2. Over here is Anne and Bob. Okay, so first one, 3 column, divide into 3 column, right? Individual 1, individual 2, and social. Plug in the utility function so you can move down the column. So individual 1, I let it be Anna. Oh, sorry, N. N, right? N, okay? So over here, UA is equals to minus 15 minus X squared minus PXA. Okay? Next, I'm given two utility function, right? Over here, UB is equals to minus half 6 minus X. Do you see now? The two utility function are what? The two utility function now compared to the earlier question, they are what? They are different. Okay, they are different now. Huh? They are different now. Okay, they are different now. Okay, so after I fill up the two utility function, I put all the information I have, all the equation I have on the right hand side. What are the equation I have? Of course, this is quite a standard equation. X is equals to XA plus XB, right? And what's the next equation? I know that the price is equals to 24. Okay, these are the information I have. And that's all. That's all. Okay, that's all. Okay, Ken? So, what did I teach you? Look, step 1, write down the two utility function. Okay, put in the 2 column, prepare to move downwards. Okay, and also put in all the extra information, because you need all this information to convert the variables inside the equation on the right hand side. Whatever that's given you, only over here they only give you 2. Okay? Okay, Ken? This is step 1. Step 2, divide into 3 column. Okay? Now, let's take a look. Step 2, divide into 3 column, right? Then step 3, I need you to do what? You can go into each column, all the utility functions, separate utility function column, and move downwards to get the optimal optimal consumption here and optimal consumption here. But before you do that, remember my 4-step model? You need to what? Go into utility function and check the number of variables, because all this will be used to turn then to convert or transform the utility function before you work on it. Remember, in this type of question, you need to use the information in the question to transform the utility function before you start to work on it. This is quite important. Huh? Okay, so let's take a look. How many variables are there? I have XA and X. Over here, XB and X. How many variables? There are what? 3 variables, right? In these two utility functions, you have XA, XB, and X. How many variables I need? I only need how many? I only need how many variables? I only need 2. That means the information there is for you to convert it into only 2 variables. Okay, I put it this way. You want to put all the other things, right? In this whole equation, apart from the number, right, I have total there are 4 unknown. If you want to put it this way, you have XA, you have XB, you have X, and you have P, right? So let's use the information. Use, this one become 24. Okay, this one become 24. Next, use, this one become XA plus XB. This one become XA plus XB. So something interesting compared to the earlier question. In this context, right, they don't let you choose the variable. Earlier question you can choose what YA, YB or XA, XB, right? Over here you can't choose. Sometimes it's easier. When you are not given a choice, it becomes easier. Some of you prefer the case where you are not given a choice, right? So over here you are not given a choice. So the 2 variables are chosen for you already. It's XA and XB, and they are actually a choice variable. Which is not surprising. That means over here, I will decide on how much spray I want to buy, XA. Over here, this guy will also decide on how much spray he want to buy, XB. Okay, so look, your utility function is transformed into what? Into UA is equals to minus 15 minus XA minus XB, right? Okay, square minus 24 XA, and your utility function is only in terms of 2 variables. Okay, and your choice variable is XA, and this is the variable that is by the other party, but which will also affect you. In this context, you know already, the more spray he buys will affect me positively, right? In this context. Okay, next, over here, so I transform this side. Now I need to transform this side. UB is equals to what? UB is equals to minus half 6 minus XA minus XB squared minus 24 XB. Again, for this equation, my choice variable is XB, and of course, I'm also affected by the action XA of this party. Okay. Now, utility equation transform. Okay, I can move downwards. How to move downwards? This one. I need to choose the XA that maximize my utility. So I dUA over dXA, differentiate with respect to XA, math again, minus 2, 15, chain rule, minus XA, minus XB, 2, become 1. Differentiate inside, minus XA become minus 1. Minus 1, so this one will what? Disappear, right? Okay. Again, I don't want to go into math. Minus 24 equals to 0. Okay, let's continue on. Over here, this will be what? 30 minus 2XA minus 2XB minus 24 will be equals to 0. Then you'll have 2XA is equals to what? 30 minus 24 is 6. 6 minus 2XB, right? Okay, XA is equals to 3 minus XB. Okay, XA is equals to 3 minus XB. All good? Okay, let's go into the other side first. The other side, we have what? Differentiate dUB over dXB. Over here is differentiate is become minus 1. 6 minus XA minus XB power 2 become 1. Differentiate inside, minus XB become minus 1. So this thing disappear. Minus 24 equals to 0. Over here, my XB is equals to what? My XB is equals to 6 minus 24 is what? Minus what? Minus 18 minus XA. Right? So, first thing first, the 4 step for checking the math here. I don't know why they like to play with this, okay? 4 step. Okay, first one, XA and XB are both not number, right? But XA and XB are equation. So you have a choice to what? Solve simultaneously. And you cannot use symmetry approach here because the equations are different, okay? But before you solve simultaneously, what check do I ask you to do? Remember? Check whether this function, will it be strictly, will it be strictly negative? No, right? Because 3 minus XB, it depending on XB. If XB is 1 or 2, XA will be positive. If XB is a lot more, suppose XB is 30, XA will be what? Negative, right? So over here, this function, this XA can be positive or negative. So save. Equation 1. Prepare. Now on this side, hello. Yes. XB, I don't care how much I use, okay? Even if when I use 0, XB will be what? XB will be negative. So this equation is what? Strictly negative. When this equation is strictly negative, do I need to have a second equation and solve simultaneously? No. When this equation is strictly negative, I already have the answer for XB. My XB will be what? My XB, because of the fact that what? Because of the fact that from this equation we know that XB is strictly negative, right? I know that my XB star, the lowest I can go is equals to what? 0. This will be my answer, understand? Even my optimal one is negative, right? But the lowest I can go is 0. So this will be answer. Remember this mathematical check. Can? Okay, 0. So once I know it's 0, right? Straightforward. I can what? I can plug this 0 inside here. And my XA will be equals to what? My XA star will be equals to 3. Answer. This is the answer. It's not hard, right? Not hard. This one is for part B, okay? This 7 marks is for part B. If everyone choose on the basis of their personal benefit, when they look at the problem individually, I choose my optimal amount individually. That means I look at my individual utility function. For board, I look at my individual utility function. What is the amount I consume? N will buy 3, Bob will buy 0. This is for part B, 7 marks. Can? Okay, now let's go into part A. Okay, the central column. Remember there are always 3 columns, right? Central column. Okay, central column. U is equals to what? Social utility UA plus UB. Okay, so in this case, U is equals to UA. What is UA? This is your UA, right? Minus 15 minus XA minus XB squared minus 24XA. Can? This is your UA plus your UB. This is your UB. I'm going to teach you something here. Okay, so in other words, become what? Minus half 6 minus XA minus XB squared minus 24XB. Okay? Okay, I'm going to teach you something here. Okay, I'm going to teach you a shortcut here. Of course, you can, in this social utility function, you have XA and XB, right? Your variable, you have your XA and XB. So I can always differentiate with respect to XA, set it equals to 0, differentiate with respect to, and I'll get an equation, differentiate with respect to XB, set it equals to 0, I get another equation, I can solve simultaneously, right? So now I'm going to teach you a shortcut, okay? Listen here, the shortcut, this is for check tree, right? In my map, you have your 4 step and you have your check tree. What is your check tree? Check tree is this. When you solve for, this only apply for social, okay? Social. Because sometimes it can be too tedious. We did earlier what? Slightly tedious, right? Okay? Is what? If it is a positive externality question. That means what I do affect the other party positively. In this context, you know, the more spray I buy, the more spray N buy, bought will benefit. The more spray bought by N will benefit. In the context of positive externality, it could also be considered as a public good. Because the spray, when the more I buy for it, right, I cannot prevent bot from consuming the spray. I say, put it in this way. When I invest in the spray, I buy the spray. I cannot prevent bot from benefiting from the spray, right? It is also like a public good. So whenever I buy a spray, I cannot prevent anyone from enjoying the benefit of the spray. It's a public good. And this is always for positive externality. So positive externality, you always can do a check like this. And if this is the case, right, I can convert, listen, this is the check. This is a shortcut. I can, instead of differentiate with respect to XA and XB, right, I can convert this equation in the form of the public good. And the public good here is what? X. The public good here is X. X. Number of spray. Okay, so what you can do is I can convert this equation in terms of X. And I just need to differentiate with respect to X. I will get the answer. Okay, remember what I say? Only when what I do positively affect the other party, I can check whether it is a case of a public good. Negative, forget it, okay? And in this context, it is like a public good because the more I buy, right, I cannot prevent anyone from enjoying the benefit, right? So it can be considered as a public good. So when it's a public good, right, I just need to look at one good, that public good, that one good, which is what? Which is X. So what do I do here? Look. Slowly. This one, can I put in like this? I put a bracket here. Plus. Right? This one also, I put a bracket here. I put back the bracket. I put back the bracket. Plus. So when plus, this whole thing become what? XA plus XB become what? This become X. One done. Over here, XA and XB. Don't worry, they will set the equation nicely so you can convert one. Okay? Become what? X also. 2 done. Of course, I still have my what? This. Okay? Okay, all look. This is not hard, okay? Minus 24, I put it behind. Okay? Can I put this behind? Okay? Next, if I factorize out minus 24, what will I have inside? When I factorize out minus 24, these two terms, when I factorize out minus 24, what will I have inside? XA plus XB, which will be equals to what? Which will be equals to X. Right? So practically what I have, I can convert this into what? I can convert this whole thing, the one, these two terms, I can combine them and put it into what? This one you know, minus 24x. I can convert this into minus 24x. I mean this equation is much more friendly, right? Much more friendly. And to solve for the socially optimal one, it becomes very easy because I just need to du over the x, the like probably good, okay? Du over the x. Okay, what's my du over the x? Minus 2, 15 minus x. Okay, 2 become 1. Differentiate inside minus 1 become plus. Okay, this one minus 1, 6 minus x. 2 become 1. Differentiate inside become plus and minus 24 and set it equals to 0. Okay, set it equals to 0, and what I have here is 30 minus 2x plus 6 minus x minus 24 equals to 0. And 30 minus 24 is 6, 6 plus 6 is 12, 12, 12, 12, and this is minus 3x is equals to negative 12. So x is equals to 4. That is my answer. So the socially optimal amount of spray for the whole society that will maximize the total utility of everyone is 4. But if I let them choose separately, what's the total they will have? 3 plus 0, which will be equals to what? 3. So remember I say, when something is positively affect other people, right, you will always what? Under consume or under produce, right? The socially optimal one, that will maximize the society utility. In this society, there are only 2 persons, okay? Maximize the society utility is 4. But if you let them choose separately, total spray that is being bought will only be what? 3. Can be done. Come back here again. Suppose n minus 1 new settlers come to the area. So they add in more player, n minus 1, with the same utility function as Bob. Okay, let me ask you a very simple question, okay? This one like primary school. When n, so it's like n minus 1 Bob come into this area. So how many Bob are there? N Bob, right? Okay, n Bob, okay? So total now, that's, okay? N minus 1 Bob come together. My wife was telling me this very interesting thing. He's a primary school student. Say, one of this primary school question. There are 4 persons in front of you and there are 11 persons behind you. So how many people are there all together? Primary student will, you know, that's how cute primary student is. 4 plus 11, so total there will be 15 persons. Then how about the one in the center? It's not a person. okay, sorry. Okay. M minus 1 come in. M minus 1 come in. Hey, you'll be shocked. It's quite cute, okay? N minus 1 Bob come in, there will be n Bob. Okay, so for individual 2, now the number become what? There are n of them, right? There are n of them with this utility function. With this, okay, there are n of them. Okay, maybe I use purple color. Okay, there are n of them with utility function n. Okay, n of the individual. Of course, over here there's still only 1. There's only 1. So total number of players is n plus 1, right? N plus 1. But n of them have this utility function and one of them has this utility function. Okay, so now they say, how do you answer in part A and B changed? A bit disgusting, huh? Okay, let's do the part B one first, part B, individual one first, okay? Okay, look, I know it's going to be disgusting, but try your best. Try your best, huh? Try your best. Okay. Okay, so go back to square 1. Don't take shortcut. Go back to your square 1. So this become P, this is X. Okay, first thing first. When the number of player change, something change over there also. Okay, don't just look at this. Okay, when the number of player change, what happened here? Look. The price will still remain the same, right? Because your price taker, no matter how many people are buying your price taker, right? Still 24, okay? So, this become what? So, the total number of spray become XA plus summation. Summation coming in. I equals to 1, Bob 1, Bob 2, Bob 3, okay? All the way until Bob what? Bob how many? Some people say n minus 1, right? I'll slap you, right? Okay, that's why the reason. Okay, there will be how many? N Bob, right? There will be n of individual with Bob utility function is like n Bob. Okay, so over here I can have x b I, right? So xb1 is like the amount of spray that Bob 1 buy. xb2 is like the amount of spray that Bob 2 buy. Understand? All the way until xbi. Can? Okay, can. So this whole thing changed. So think of this. When there are more players, when they introduce more players, this whole thing changed. So when this whole thing changed, take note, because these are the 2 equations that you're going to use to transform the utility function. So your utility function will change. It's not the same utility function anymore. Hello. Okay. So over here, this one still the same because it's PC, perfect competitive market. No one can affect the price. 24. Okay. Now this one. How do I use this one? X become what? X become XA plus summation I equals to 1 to n xbi. This will be my new utility function. So my new utility function will be what? UA is equals to minus 15 minus XA, okay, minus summation I equals to 1 and XBI, close bracket, square minus 24XA. This will be my new utility function. You have to write this utility function down to know how the shock affect the utility function. Because the shock affect the equation, and you plug it in, this is your new utility function. Okay, and do the same thing here. Because we are looking at this column, right? This column is straightforward. So I will dUA with a new utility function. I can find my new optimal one. dXA is equals to what? Is equals to differentiate. Okay, the beautiful thing. What is the beautiful thing? All this here, they are all what? This whole thing is a chunk of constant, right? Because I'm differentiating what? What is my choice variable here? I'm differentiating with respect to XA. So all this is what? Constant. So when all this is constant, I can ignore it. It practically become what? Differentiate this become minus 2 chain rule 15. Right, I write down this whole thing minus XA minus this whole thing. I have to write down summation of I equals to 1 to n x b I. Okay, 2 become 1. Differentiate inside. What is the only term I need to look at? This. These two are what? Both constant. So differentiate inside. Minus 1 become plus. Okay, minus 24 equals to 0. Right? Okay, then from here, I can find out the answer. What is my XA? 30 minus 2XA minus 2 then summation of I equals to 1 and XBI minus 24 equals to 0. So what is my XA? My XA is equals to, bring over 30 minus 24 is 6. 6 minus 2 summation I equals to 1 and XBI, and after I divide by 2, so this 6 become 3, and this is my equation 1. Okay? Because it's not a constant, so I cannot derive the answer yet, so it will be, I will have an equation. It's called my best response function. So, okay? Okay, so given how much each bob or different bob can, different bob can have different one, okay? Okay, different bob, all the bob add up together, how much they, all the bob add up together, how much they buy. I plug it in, 3 minus that one will be the optimal amount of spray I should buy to maximize my utility. Equation 1, okay? The other side, okay? The other side, 24, this become what? Summation of XA plus summation of I equals to 1 and XBI. Can? So what's my new utility function? Again, when the right hand side information change, right? When I put it in, because I need to transform my utility function also transform differently, right? So UB is equals to what? UB is equals to minus half 6 minus XA minus summation I equals to 1 and XBI squared minus 24XB. Okay, but it's more tricky now. Do you know why it's more tricky? When I differentiate with respect to B now, okay, this is my transform utility function. When I differentiate with respect to B now, XB, okay? Okay, a few things. First one, XA is constant, right? Next, I only talk about XB. Second one, this is the trick, which some of you may not like it. There are n bob. So I have to look at one representative bob first. One more time, there are n bob. Suppose n bob, okay? Because it's not, okay, never mind. Bob 1, bob 2, bob 3, bob 4, all the way until bob n, right? So I want to look at one first. Look at one of them first. Whenever you have n number, right, you look at one of them first. So I look at bob 1. Bob 1, bob 1, bob 1. Okay, if I look at bob 1, what will I have here? Look, bob 1. So this one will be what? XB will be what? Bob 1. Okay, I look at bob 1 first. And over here, what is this term? This term will be what? xb1 plus xb2 plus xb3 plus xb4 all the way until xb what? N. So when I differentiate, now I need to look, I need to differentiate with respect to, because I look at Bob 1, right? I need to differentiate with respect to xb. I need to look at what is the optimal consumption for Bob 1, right? So I need to differentiate with respect to xb what? 1, right? So over here got xb1, xb2, xb3 all the way to xbn, right? So I need to take out that what? I need to take out that xb1. So this one I have to change it to what? I have to take out the xb1. So this one I have to change it to xb1 plus summation I equals to 2 all the way until n xbi. Then this and this I can differentiate. This one I can treat it as what? Constant. Take some time to digest. Hey, back to this. So I will have a what? I will have a new utility function. What is my new utility function? I can write again. This will be what? UB is equals to, okay, this one disappear, right? Okay, come. UB is equals to minus half 6 minus XA minus what? Over here, minus XB1, right? This is replaced by this. Minus summation of I equals to 2 to the, then n xbi squared minus 24 xb1. This will be your new utility function, right? Because this term is replaced by this term. So that I single out the xb1. Because Bob 1, the control variable for Bob 1 is xb1. In the summation, I need to take out the xb1 to differentiate. The rest, I keep it inside the summation. Because the rest will be considered as constant. What Bob 2, Bob 3, Bob 4, Bob 5 truths are all constant. Understand? Okay? Okay, once you understand this, I can differentiate dub over d what? xb1, right? And I can have what? Differentiate this, become minus, differentiate inside 6 minus xa minus xb1 minus, I copy this whole thing because it's chain rule. Okay, I copy this whole thing, xbi, okay, over here. Then differentiate inside. Okay, now differentiate inside. Oh, I shouldn't write 1 and I, look very similar, okay? Differentiate inside, there's only one term inside to differentiate, which is this. Which is this, right? So xb1 I differentiate become what? Minus. Right? 2 minus 1 become 1. Then I differentiate inside xb1, differentiate become minus. So this term over here, minus 24 equals to 0. Then I can make xb1 a subject of formula, which is what? xb1 is equals to, I bring this over, I bring this over is minus 18 minus xa minus summation of I equals to 2 all the way to n xbi. Then this will be my second equation, right? But before I solve them, what did I teach you? Look here. This equation can be positive or negative, right? Depending on xbi, depending on this whole term. Okay? But this equation, again, minus 18, minus xa, minus this equation, strictly, xb1 will be strictly what? Negative. So if xb1 is strictly negative, means what? We know this thing. Your xb1 star, okay? If this equation is strictly negative, your xb1 star will be equals to 0. This is your answer, okay? Because from this equation, I know that my xb1 will be strictly negative. And since, look, since all the bobs are symmetric, because xb1 is 0, bob 1 will choose to consume 0, bob 2 will also be 0, bob 3 will also be 0, bob 4 will also be 0, right? So that means xb1 0, xb2 0, xb3, because all the bobs are symmetric. So once you know this, hello, what we have here? Look, that means summation will be 0 plus 0 plus 0 plus 0 plus 0 plus 0. That means this entire thing will be what? 0. So my xa is equals to 3. And this is what happened when, don't look at the central column, these two, okay? When n minus 1 bob come in, this whole thing change. Utility function will be transformed, and with the transform equation, you have to differentiate with respect to xa, and accordingly, And you have to differentiate respect to xb. In this case, xb1, look at one representative one. Okay, because there's a number here, n of them. And you realize that the answer will not change at all, right? Total amount of spray will be n is 3 plus all the bob. All the bob are very selfish. Okay, they're all 0 still. So total amount of spray will still be what? 3. Answer to B never change. And this is the working behind the exam commentary, which just say students should point out that there will be no change to part B. Okay, this is the working, okay, Ken? Okay, come. Social. Utility function A. This will be the new utility function. Write down. Okay. Again, exam commentary don't have all this working. Minus XA minus summation of I equals to 1 and XBI squared minus 24XA. Right? This is your XA. And how about the bob? The bob, okay, look, the bob is all this. These are the utility function for what? These are the utility function for each bob. Okay, these are the utility function for each bob. Okay, each bob. One more time, each bob. So in the end, what we have here is this. Because this is the utility function for each bob, right? So I write down this minus this whole thing. Half. Okay, I can put it this way lah. I put it this way for you. Plus this whole thing. Okay, minus half 6 minus XA minus summation of I equals to 1 and XBI squared minus 24XB1, right? Oh, actually no. Actually, I have to write down this entire thing. Now I can put it this. I can put it this way. Okay, XB1. Okay, XB1. Okay, just one XB. Can? Okay. Okay. Let's take a look now. Okay, let's take a look now. So what are the things I'm going to change here? Look, first one, because over here, this is for one bob. So for n bob, n bob, because there are totally how many bob here? N. So I need to multiply by n. So this is the utility function of n plus total n number of bob multiplied by the utility function of n bob, right? This will be the total utility that is derived from all the bobs. Okay, very weird. No, actually all the bob have other names, okay, but I just say they look like bob. Not they look like bob, their utility function is like bob, okay? Can? So n multiplied by all the utility function, okay? This is 1 only, so you need to multiply by n of them, okay? Can? Okay, so let's take a look now. What did I teach you? Because it is the case of a public good. I can do the same thing. I can convert this function in terms of only what? Only x, right? Earlier, what did I do? I convert the function only in terms of x, then I du dx is easy, right? Now I can do the same, but it requires mathematical competency. Okay, one by one now, okay? Slowly, okay? How do I combine? Okay, this is your new x. XA plus I to the power of I1n xbi. So what is this? XA. So when I do it this way, plus, right? You all can see. Okay. Okay. So this whole thing become what? This whole thing become x. So this whole thing will become x. Okay? This whole thing will become x. Okay? One done. Okay? Next, over here, same thing. Look, I can just put a bracket here. This become plus. Right? So when I open bracket, become minus. And this whole thing will also be what? X. Okay? So this whole thing will also become x. Yes. Okay? 2 done. Okay. Now, how about these 2? Look, these 2, okay? I bring it down for you to make it easy for you, okay? I bring it down. Minus 24 XA minus what? Minus minus 24, 24, 24, 24, 24, 24, and xb1, right? 24n, right? This is for one of them. Can? 24xb1, right? Okay. Can I represent this term? Can I replace this term with what? Summation of I equals to 1 n xbi. You understand? Because this is n times what? So it's xb1 plus xb2 plus xb3 plus xb4 all the way, right? It's the same. So once I have this, what I can do? I can factorize out 24. Inside I'm left with what? Minus 24 xa plus summation of I equals to 1 n xbi. And this whole term inside will be what? Will be what? X. Right? Because n times xb1. Okay, so you have n of them. So it's practically equal to xb1 plus xb2 plus xb3 plus xb4 plus xb5 plus xb6 all the way to xbn. Okay, so it's a summation. So once you have this two term, I can turn it into what? Minus 24x. So it means what? It means what? Look, means I continue here. Okay, this term, okay, and this term, I can turn it into minus 24x. Right? Okay, this will be your new utility function. Then it is so easy, right? You can differentiate du over dx. I will get what? Differentiate this term. I will get minus 2, 15 minus x. Differentiate inside minus 1, so become plus. Over here, differentiate this one, differentiate this one, differentiate this one. This is minus n over 2. So it's what? 2n over 2. Hey, you all understand? I don't want to go into the math, okay? Because this one, n, I can put it in here, minus n over 2. So when I bring it down, is what? When I bring it down, hey, this one I can put it inside here. Hi, you want, I can do it for you. I can put this inside here for you. Okay, so 2 become what? Become minus n 6 minus x. 2 minus 1 become 1. Differentiate inside, become minus 1, become plus. Over here, minus 24 equals to 0. Can? So after that, I open bracket, 30 minus 2x plus 6n minus nx minus 24 equals to 0. Then I make x the subject of formula. Over here is 2x. I bring x to the other side, plus nx equals to 30 minus 24 is 6, right? 6 plus 6n, right? Then I can differentiate out x is 2 plus n equals to, this one I can differentiate out 6, 1 plus n. Then my x will be equals to 6, 1 plus n over 2 plus n. This is the answer. So the socially optimal one actually depends on the number of bob. Okay, so the socially optimal amount of spray depend on n, which is not surprising because they never give you the exact number of bob inside the question, in the context of the question. So it depends on the n. But one thing we learn, okay, this is what they put in the exam commentary. So they just jump to here. Okay, but this is what happened. I show you what happened. Okay, so this is what happened. And when n tends to infinity, x will tend to 6. So this is the n. But of course, I don't think you need to add in this. So when there are more and more bob coming in, when the number of bob is a lot, right? The socially optimal will tend to 6. And this is mathematical competency again. Don't ask me to show you. This is your limits. Understand? Can? Okay, but I think this is enough. Okay, can? Okay, so this will be the answer. So, is there any change to part B? No change. Is there any change to part C? Yes, because the socially optimal amount of spray now depend on the number of bob. Of course, you can take one extra step because the math equation is here, right? To show, oh, what if the number of bob go very, very big, that means 10 to infinity. What will be the social optimal amount of stray be? This is math again. Can? Okay, so this question, a lot of math and math and math and math. Unless, but I do all the steps for you as well as I tell you all the check. Remember check 1 to check 4? Take note of my check. Step 1 to step 4 to do this type of question, right? And as long as you follow them, I don't think it'll be a problem. But if you are not comfortable with math, right, try not to attempt this question.